Hey guys, I just wanted to hop on here really quick and just discuss this blog that we just published. What it primarily focuses on is our vector search endpoints and then these vecdb endpoints. So the vecdb endpoints are included in the database API, which has been in ORDS for quite some time, but it adds new endpoints to it for doing different vector operations to support like your vector database. So that's one part of it. I guess the star of the show is the vector search endpoint. So it's a post endpoint and it's automatically included for auto rest enabled tables and views. The only requirement is at least one vector column needs to be in that table or view. Those are the two main endpoints for this application. And in this video, I want to show you what those endpoints look like in database actions or SQL Developer Web. So the vector search and then the DB-API. And then we'll just spin up the application and then spin up ORDS just so you could see that. Now the focus isn't going to be really the application itself. It's just like a vessel to show you this use case of using vectors. But let's go ahead and start. I will just show you this live lab here. So it's actually called Getting Started with AI Vector Search. Okay, this is produced by another team at within Oracle. It's the vector database team. But when you're here, you can just preview the sandbox instructions. If you want, you can click run on your environment, and then you can do all this in your autonomous database. If you have a like base database service, or if you're in a container, you can do the same thing here. The method that you would go about loading the model would be different. So this uses object storage to load the model into the database. So that would be like the only big difference. If you just go to lab 1 and then just do tasks 1 through 4, that will get you exactly where you need to be to follow along in our blog. What you effectively are doing in this lab here is you're loading the model, you're creating your parks table, your parks images table, you're loading the data into your parks and your parks images table, and then you are vector embedding at least one of the columns. So in the case of this parks table, we take the park description column and then we vector embed it. So then we'll have a description vector column, which you'll see here in a second. There are two benefits with you completing task 4. You can complete this lab if you want to, or you can just come back and then you're ready to go to work on the blog. Okay, I'm going to head over to the sample application and I will just go ahead and I'm going to start up ORDS first. You do not need to have a like self-managed or customer managed ORDS deployment. You can use the ORDS that ships in the autonomous database. I was just doing some testing here, so that's why I have a second pool. You can see down here, I've got ORDS pool 2. So backing up, when you perform an ORDS installation in the autonomous database, you're not replacing that ORDS that's already in the database. What you're doing is you're just creating a second pool. So any HTTP requests that have like, ORDS / whatever your pool name is are going to be funneled through this ORDS and not the ORDS that ships with the autonomous database. The pool name is implied in that path. So you're probably familiar with just like the ORDS /. Typically you would have the pool name afterwards. That's the default way to map your URLs. And since the pool name it's a default pool, it's just implied. So there's no we don't put the pool name in there for the default pool, right? Now that this is up and running, we can sign in here to database actions or SQL Developer Web. And I'm using the National Parks user or schema, which is the same thing that the live lab that we stole from, or that I stole from, uses. So let's go to the SQL Worksheet first. All right, and I'm actually going to just filter, just to make it a little bit easier for you to see. But you saw there's a bunch of different tables and there's other objects in here as well. So that little plug means that I've already got this REST enabled. And if you hover over it, if you hover over the object, you can see it's already REST enabled. But if it wasn't, this disable would say enable, and then you'd enable and REST enable it. But since we've already done that, our two options are disable and curl command. So if I click on curl command, you can see all the different endpoints here. You've got your normal ones, the ones that we've always shipped, and then we've got this new one down here. That's the vector endpoint. You got your sample curl command right here, and then this would be the payload that you could send when you do this post request. Remember, the vector search is a post request, and then you can actually select some of the properties that you would send in the payload. That's one way of looking at this. But if you go to the REST workshop, this might be a little bit more familiar because you can look at the table in the OpenAPI view. So if I just focus on the vector search right here and click try it out, you can see that this is what a sample payload would be like if you were going to send a vector embedding to perform a search on a target table. So a couple like considerations with this, a lot of this stuff is like default, right? So like ascending, the default is true. So you don't actually need to include that. If you don't want, you can omit that. And then for the columns that you want to pull back, if you do not include columns, it's just going to pull back all the columns in your table. And then for the distance metric, you do not have to include that, but I would. The reason why is because if you don't include that, then the distance metric that is used is cosine. However, the model that this lab uses, right, this all mini LM L12 V2, this model was trained and fine-tuned using the cosine similarity. So the best practice is to choose a distance metric that matches with whatever the model was trained on. So in this case, we don't have to include cosine, because it's already automatically cosine, so that makes it easy. A lot of this stuff is a default as well. So we can omit everything except for the vector. I'm kind of rushing through this because the idea is like you already kind of know a little bit about the vector operations in vector database, so I'm not trying to teach that. This is just providing you the information for like how like these endpoints work. Probably easiest for me to show you the second endpoint that we work with here. I will start up this node server. This is the actual application. The reason why I'm doing this is because in the application, I included some like helpful tabs up here. And one of these tabs is it's a subset of the database APIs. It's all of the new vector database endpoints. One that we want to focus on is this vecdb embed endpoint here. So this is the endpoint that you would use initially, or at least this is how we do this in the application, where hypothetically, or for instance, like a user would enter in like a search query, and then before you can perform a vector search, that search query needs to be vector embedded. These are the two things that you would send at a minimum. Would be the model name, which again would be this right here, and then the second part is actually the text. Now that you know what these what these endpoints look like, what I can show you is like actually what the application looks like, and you can kind of picture in your mind like what's happening on the back end. Let's do that now. Let's look at the application. It's very, very basic. This is just a very similar use case where you have target data stored in your database and you want to perform a query on it. You know, this use case can be applied to forecasting or retail, financial markets, anything. In this case, we're just using national parks data. So you as a user could go in here and you could type in like your free text stuff, whatever you want, or you can just use these quick picks, right? This is just a design choice. I'm going to use the mountains with hiking trails quick pick because that's what a lot of the examples use, and it'll make a lot of sense when we start connecting everything. But the idea here is we click this search button. So if you look at the actual HTML, this is our form, right? Which is, you know, this box right here. And then we're looking for the search button right here. And then there's a JavaScript listener that's attached to that, and that's what kicks off all of the post requests. So on our front end, what's happening is user interacts with the application. They enter in their query, they hit the search button, and then on the web server side, right, that text is put into a JSON payload, and that is what you see here, right? So we've got the JSON payload. It would be text, and then that text would be mountains with hiking trails, right? So that would go in here, mountains with hiking trails, and then the text model would be mini LM L12 V2. Your ONNX model is already loaded into the database, so if you just did tasks 1 through 4, you would already be there. You'd already have your model in there, and you would have already performed the vector embedding on your target database or your target table. So anyway, if we're going back to what the application is doing, right? As soon as we hit the search button, it will go here, it will do the vector embedding, and then it'll come back to our application on the, it's in the server.js file. It'll come back to our application. It will take that vector and it will use that vector to perform a vector search on our vector search endpoint, this vector search endpoint. And recall, these are the endpoints for the parks table. So we have auto rest enabled our parks table, and you're going to do a post request on the vector search. Okay. So let's see what that looks like here. So if we click search, it's doing the embedding, and then it is going back out to ORDS and doing the post request on the vector search. And you can see here we're sorting everything by the cosine similarity. That's what the distance is right here. One way of looking at this is, if this is your query right here, what you're trying to do is you're trying to apply like genetic coding. Yeah, if you've like genetically coded this like query, what you're trying to do is you're trying to find like its closest sibling, like its twin brother or twin sister or something, or like mother, father, brother, whatever. And if you can kind of look at it from that perspective, like all the stuff in your database has been genetically coded. And so when you perform this search query, you're trying to find results that are like most closely linked to your query. So that's kind of how my brain works with like these vector embeddings. So if you don't really understand the maths, then you can kind of like look at it from that perspective there. That's kind of how this works on the front end. I'm trying to gloss over this because I want to actually jump back to the SQL Developer Web or the database actions, because there are a couple more things regarding security that I want to discuss. So we're using OAuth 2 client credential for this application just to be able to demonstrate the security. You can spend some time navigating the application code here, but again, that's not really the focus. The focus is, how do I go about configuring the OAuth client in database actions? What do I do with all that information that's going to be provided to me when I create this client? How do I use it? So let's do that now. So we'll go back over here to database actions, and we'll click on OAuth clients. And this is the client that we're using right now for this application. I'll go ahead and just go through this create OAuth client right here. You've got these three options right here. We're choosing client credential, and then you would go through here, you would name your client. Here's the important part of this. You are the National Parks user, right? We're in the National Park schema. So you are the one who's creating this client. So you are the owner of this. What you are trying to do is you are creating this client so that way you can assign roles or privileges, but in this case it's going to be roles, because when you're using the client credentials, you will use roles to this client. So that way the client has the rights, right, to access like these protected resources. We will create this client. I'm just going to assign it some arbitrary roles here because it doesn't really matter, okay? Because I want you to see this piece. So when you click create, what it will do is it will give you your client secret here. You will want to retain that because that's going to go into like your .env file, or you would use that for like your curl commands, or like if you were in Postman or Insomnia, you'd want that. If you forget to do that, you can always manage your secrets, and then you can rotate and revoke any existing sessions, and you can get a new client secret. I'm going to delete this because it's not really attached to anything. So this is the legit one here. This is the real one here. Let's talk about these roles right here. If you are accessing, like if you are like a valid database user and you are accessing the database API, you can do that with your credentials. But if you want a client to access the database API, you have to give it specific roles or privileges. And that's depending on what kind of OAuth service that you're creating. Again, this is client credentials. So in this case, we're just sticking with roles. If you see that we have this ORDS built-in role right here, which is specific to these vecdb endpoints. So for your client, you will want to give it the vecdb role, this guy here, because it would be used to access any of these endpoints right here. So that's for those vecdb endpoints through the database API. That doesn't include the auto-rest enabled table. If I can hover over this, you can see where it says auto-rest role, it's national parks.park. So what that's saying is the national park schema and then the parks object, which is this table. So those are the two roles that we need to assign this client, because our application will issue HTTP requests to those two protected resources. And in doing that, we will provide the client ID and the client secret to authenticate and to get an access token to use for these subsequent requests. So I said access token. If you click get bearer token, you can see all the relevant information right here. If you wanted to test it with the curl command, otherwise you could do something in like Postman or Insomnia, which I will show you right here. I've got two endpoints here. I've got the DB API with the vecdb embed endpoint, and I'm using OAuth 2 client credentials. I've got my OAuth token endpoint, my client ID, my client secret. Okay, let's kind of like work backwards from here. If I type in mountains with hiking trails and I click search, that is effectively the same thing as us doing this, which is we fetch this token, right? We get this token, we use this token, we present that token to ORDS when we go to this endpoint. And what we are doing is we're doing a post request to this endpoint, this vecdb embed endpoint, and we are using these properties in the JSON payload. We include the model, and then we've got the same query here. So if we send that, it'll bring us back this embedding on our application server, right? On this backend here, actually the server.js handles this. Essentially what happens is it takes this payload, removes the text, and then it uses this embedding, right? And then this embedding becomes the vector for the vectorSearch endpoint, okay? So then what we do is we use this vector as our like reference or the basis for comparing to all the vectors that are in the database. And before I do that post request, I'll show you really quick here. So if we go to the SQL worksheet and we look at the parks table, right? I'm just right clicking and then selecting edit. You can see here, if I go to DDL and then create, this is just like a really easy way for you to see like what the table structure is like, you know? I mean, there's like tons of different ways to do this, but these are the columns that we started with. And then when we do the vector embedding, we create a description vector column with a vector type. That's what we're kind of comparing against there. And then if I go to here, I just right clicked and pressed open, and I'll click on data. I can do a single record view. And then if I just hover over the vector, you can see that's the vector. So that's what we're comparing against. All right, so now if I go over here, this is basically what happens on the back end of this application. It just goes to vectorSearch. It is still doing OAuth 2 client credentials. You'll notice here, I have the bare minimum, which is a vector. We don't need to name the distance metric because it's cosine. That's fine. The cosine's default. But in this case, because the model was fine-tuned and trained on the cosine, we don't need to name that here. And for our purposes, it's fine if it brings this back in ascending order, and it's fine if it brings all this stuff back, like all the columns back. It's not a huge payload. It's just a really simple application. So I'm going to clear the history. You can see if we clear this, we'll fetch the token, right? And again, this would happen all automatically on the server side of the application. And then it's doing that vector search right now, okay? So if you see here, the first one is New England. This is like the New England Trail. And you can see, if you scroll down here, you can see the vector search distance is 0.458. And then if we go to the next one, the Appalachian Trail, and we see the vector search distance is 0.461. If we go to the app and then we do the similarity search here, you can see it's the same thing. So that's how that works, okay? And I think that was mostly it. Let me know what you think. You know, if you have any questions or anything or comments, them down below. Be sure to respond. But thanks, and I'll see you on the next one.